Hello and welcome to this video in which I would like to talk about an extension to the basic EOQ model, which takes quantity discounts into account. As you may recall, the basic EOQ model makes a series of limiting assumptions regarding, for example, the nature of demand and the nature of the times. But we also assume that unit costs are actually independent of the order quantity of the basic EOQ model. Clearly, in reality, that will often not be the case because we cannot expect to get a better price at a better unit basis the more we purchase at a given time. The purpose of this video is to tell you how we can extend the basic EOQ model to take quantity discounts into consideration. Now, there are two different kinds of quantity discount schemes. The first one is called an all units quantity discount, which simply means that the discounted price is for the entire purchase quantity. So in our example here, where we have a quantity discount schedule shown in this little table here, if we purchase 4,800 units or more, we will pay $8 for each of those 4,800 units. On the other hand, if we purchase a very small quantity, we will have to pay a price of up to $10. In this particular video, we will discuss the all quantity discounts. In a separate video, I will talk about incremental quantity discounts. In the case of incremental quantity discounts, the discount only applies to the increment of the order quantity that is beyond the respective thresholds. However, for now, let's focus on this upper portion of this table. We will compute the EOQ taking into account the existence of all units quantity discounts. As usual, we start out with our basic parameters. We know that a lambda annual demand is 4,800 units. The cost of placing an order is $40, and the inventory carrying charge is 25%. And now, of course, we see that the unit cost will depend upon the quantity we order in every single order. As you can see, the cost ranges from about $8 per unit for a large order quantity up to $10 per unit for small order quantities. If we were to plot out these total cost curves for these prices, we would find that we do not have a single total cost curve that we can simply optimize the way we do in the basic EOQ. As it turns out, we now have a series of different cost curves for each of those different price levels. So we end up with a discontinuous total cost function, and we'll have to be a little more careful as we try to find the truly cost minimizing point on this discontinuous total cost function. To do this, we simply start out by computing the EOQ for each of those respective price breaks. So let's start out with the lowest price break of $8 per unit. The EOQ, of course, is simply the square root, as we know it, 2 times lambda times the cost of placing an order, divided by the inventory holding cost per order. Now remember, this of course simply is I multiplied with the respective cost per unit, which in our case right now is $8. So that gives me, in this case, an order quantity of 438 units. Now the question is this actually a feasible order quantity? So what this means is that if I want to get a price of $8, do I get that with an order of 438 units? Well, clearly no. I only get a price of $8 per unit if I purchase at least 4,800 units. So what this means is that this EOQ we just computed is not feasible if I want to get this $8 price per unit. The feasible EOQ, the lowest possible order quantity for this price, is actually 4,800. Now what I want to do next is I want to compute the total cost knowing that I choose a feasible order quantity of 4,800 units, and I will pay a unit price of $8. Well, in this case, my total cost is the sum of my acquisition cost, inventory holding cost, and order cost. Remember that now it is very important to include the acquisition cost because now the acquisition costs vary with the order quantity we choose. So we have to take the acquisition cost or purchase cost into consideration here. In this case, my acquisition cost will simply be the unit cost of $8 multiplied with the total annual demand of 4,800. And now we add to that our average inventory, which is 4,800 divided by 2, multiplied by the cost of holding 1 unit of inventory for 1 year. And then we add to that our annual ordering cost, which is annual demand divided by the order quantity of 4,800 multiplied with the cost of placing an order of $40. So we find that in this case, we would be looking at a total cost acquisition, inventory holding, and ordering cost of $43,240 if we were to go after that lowest price break. Now let's do the same thing for the other options here. So what if I want to pay a price of $8.50? At first I'll go ahead and I'll simply compute the EOQ again the way we've done the this before, 2 times lambda times K divided by the inventory holding cost per unit per year. And you'll see that my EOQ now is 425 units roughly. Again, I asked, do I actually get this price of $850 with the EOQ? The answer is of course no. As you can see here, I have to order at least 1,200 units to get this price. So my lowest feasible EOQ for this order quantity closest to the truly optimal EOQ would be 1,200 units. And again, I will compute the total cost associated with this solution. So we'll be looking at an acquisition cost of lambda times the unit cost of $850, adding to that our inventory holding cost, as well as our annual ordering cost. And you'll see that we end up with a total cost of $42,235. So as you can see, that we're actually better off paying a little more on a per unit basis, $850 rather than $8. We'll end up with a lower total cost. The reason is we'll hold much less inventory. Now we'll keep going with the other price breaks as well, just to see what happens. Let's take a look at the unit cost of $9. So again, we compute the EOQ as the square root of 2 times annual demand times the cost of placing an order, divided by the inventory holding cost per unit per year. The EOQ is 413. We ask, is this EOQ actually feasible? And yes, this time it is. If I order 413 units, the price of $9 is actually what I'll pay. So in this case, the EOQ is the same as the feasible EOQ. And now we'll go ahead and compute the total cost associated with the solution. So it will be the annual demand multiplied with the $9 unit cost, add that to our inventory holding cost per unit per year, and of course the annual order cost as well. So you see the price, the total cost is now higher, it's $44,130. And the reason is that although we hold less inventory, of course we'll place more orders and also we'll pay more on a per unit basis in terms of acquisition costs. And now finally, just for the sake of completeness, I'll do the same thing for the $10 price break. My EOQ with a $10 price break will be equal to 392 units roughly. Is this a feasible EOQ? Yes, it actually is, because it falls into the relevant price range. So again, the feasible EOQ will be the same as the EOQ we just computed, and we'll compute the total cost as well. So that will be lambda multiplied with unit cost C, and then we'll add to that the inventory holding cost as well as the annual demand order cost. And you'll see again that our total cost is now higher than any other options. And of course the reason, the main driver being the added purchase costs. So I hope you kind of see what we did here as we simply went through the basic EOQ procedure first. We computed the EOQs and then asked ourselves, well, are these EOQs actually feasible? And again, by asking this question, we simply mean, will I get this respective unit price if I choose the order quantity? And clearly, as we see up here, for example, the answer is no. If I order only 438 units, I will not pay $8 per unit. But rather, if I want the price, I will have to purchase at least 4,800 units. So we compute the total cost associated with each of these feasible order quantities, and we'll simply select the solution that minimizes the total sum of purchase costs, inventory holding costs, and order placement costs. That concludes our demonstration of the all units discount. If you have any questions, as always, please be sure to let me know and come back for more in the second video as I talk about incremental quantity discounts. Thank you for watching.